Hey everyone, Team LS1 here. This is our final project on the topic of trends surrounding the COVID-19 pandemic. So I'm going to go ahead and share my screen here. So just a quick overview of our presentation. We'll start by describing our data and posing a hypothesis about shelter-in-place policy and policy response. And then we will present a series of visualizations that will help us either confirm or reject that hypothesis. So a little bit about the data set. We sourced two data sets from covidtracking.com, one with information specific to states and one on a more national level. These data sets contain records on testing and hospitalizations, patient outcomes, all those kinds of metrics from 50 states, and then of course 5 territories and the District of Columbia as well. So the records span dates January 22nd to whatever the current date is. But for the purposes of this project, we decided to cut it off at July 31st. So our null hypothesis here is that shelter-in-place orders resulted in no significant difference in death count, while our alternate hypothesis says that there was indeed a effect in terms of decreased death counts and lower infection rates because of the shelter-in-place orders. So this time series visualization shows tests conducted over time. And as you can see, testing was quite slow, virtually non-existent in the early days leading up to the pandemic. But then around mid-April to late May, things really started to pick up. And then now when you look ahead to around August and beyond, COVID testing clearly appears to be a lot more available.
Next, we looked at COVID-19 versus traditional epidemiology factors. This included the state poverty level, whether there was a major port of international travel, and population density. This was examined across the total positive infected, the recovery rate for those infected, and the average death rate. Unfortunately, the recovery rate data was missing from several major states, and thus it would have been unjustified to really demonstrate that data here in any visual representation, as it may be misleading. However, fortunately, the death rate as well as the total positive infected really correlated strongly, so one graph for each represents it fairly well. What we can notice starting on our left-hand side here is that states of the 8 states that have a higher death average or higher death rate above 1 in 20 chance to die if you were to contract COVID-19, 5 of those states have international airports. What we can also notice is that there's an upward trend, primarily for larger population densities. The larger population density is indicated by the rather large circular shape. For instance, DC, being a city versus a state, has a massive population density. And what we can notice is that there's a yellow coloration indicating a international airport. What we can also notice here is that in the lower right quadrant, as well as the last quartile here of our data for poverty, we can notice that there's a large trend of very impoverished states that have no international airport, which is rather interesting of itself. And what's also interesting is how DC would compare to the rest of Virginia. What we can also notice from this then is that the state and city level data may be significantly different, especially when we look at it across a large state such as California or Texas. Because you may be wondering where California is. California actually does not have a huge population density versus something like Massachusetts or Rhode Island. So skipping over to our right-hand side and looking at it from a geographical perspective, though, we can see the total positive infected rate versus a major airport indicator. And we can see that large states with major airports have a huge number of infected. But what happens when we look at it from a perspective of total positive infected versus the average or the total population of the state? So looking at it from a factor of it, we can still see that there actually isn't too much difference if we were to present that here today. We can still see that something like Oregon, with a low population density being in the lower 10 states for population density, still has a very low number of cases compared to something like California, especially on a per person capita. It may be more interesting to see how this data progresses, especially as we get closer to a vaccine, because vaccination rates often have a strong correlation with poverty levels.
On May 7th of 2020, the global maxima hit for daily increases in deaths. It was about 2,700. The global maxima for positive case increases occurred on July 17th, 2020. That was about 77,000. Looking at the death cases increases, we can see hopefully we should be okay. We've hit that max back in May, right after the state of social was put in place. So I hope not to have to see another one. But yeah, overall we see that May 7th, where that max hit, we see the death rate slowly flatline, and then these sort of indicate the severity of those increases. Overall, let's see how the curves look. So early March, May, that's when the stay in shelter was put in place. End of May is when the stay in shelter order was closed. So after that, you see the death rate decreased. However, the positive case increases increased. Again, this is from the current month minus the previous month divided by 30. That's how you get these rates. So as you can see, the positive rate did have a sharp increase in the past couple months. Overall, we see the positive cases, California, Florida, and Texas have been sharply increasing. And we can see that again with the rate changes. Overall, from June to July, there was a sharp increases in all of these months and all these states. Overall, the deaths by state, you see the severity by state, California, New York, and New Jersey, Rhode Island as well. Let's see how the death rate look like. So most of the states have a dramatic decrease in death rates, as I was mentioning before. You see New York dramatically decreased from 470 to 100. Same in New Jersey from 284 to 100, which is severe. That shows how strong the state is doing now. Recoveries by state, we can see Massachusetts has the most amount of recoveries, Texas with the second. This is my epidemiological chart that shows the severity of COVID-19 on the effect of the state. New Jersey was the most affected, smallest population with the greatest amount of deaths. In the next slide, we'll see how it looks with another portion. So this is the same graph as before. However, we're not doing division, making a metric out of it. We're just showing you the deaths divided by population, right? So you see the ones that are deeply colored blue show that they have the most amount of deaths. However, in the previous plot, that metric, right, New Jersey had the most. So it's important to make these epidemiological metrics. Another metric is CFP, case fatality proportion, deaths divided by total positives. We see that Connecticut has the most, and New Jersey following. Also, same kind of thing, deaths divided by total positive. You don't see Connecticut even on this plot, so it's very important to make those metrics.
Hi everyone, for this presentation, I will focus on the test and positive cases of COVID-19 growth in the United States and the relationship between these two variables. Here's an overall graph which shows that both the number of tests and the positive cases was keep increasing from January to July. Also, it's clear that the test number grew faster than the positive cases. To learn more detailed information by state, I created maps month by month. I started from March since this is the time all the states began to conduct tests. In this graph, the size of circle means the number of tests and the color of value means the number of positive cases. So we can see in March, every state only conducts small size of tests and there is no huge difference among the states. I went to April. New York stood out, which had more tests and positive cases than other states. Coming to May, all the states has their tests and the positive cases grew faster. And in July, we can see New York, New Jersey, Florida, Illinois, Texas, and California stood out in the map. When to July, all the states has much more tests conducted and positive cases compared with March, where we began.
This is Kalaivani, and I'm here to talk about my part. I did exploratory analysis with the time series visualization. Here we could see that some of the data entries are inconsistent as there are no records available for some of the dates. The reason behind this is the data is being updated by the volunteer outreach team who are in contact with authorities in every state and territory. Hence, I decided to go with the data quality grade column, where the data is ranked based on the assessment of the completeness of state reporting. The next graph is for currently hospitalized patient count and ICU patient count. From this graph, we can see that the number of hospitalized patient counts are higher during the starting phase of the pandemic, that is April month, and the count get decreased during the lockdown period. And once again, after reopening the state, the number of hospitalization increases during the July month. On the other side, when we see the ICU patient count, it doesn't show much extreme variation when compared to the hospitalized count. When COVID-19 first hit the United States, it spread through different races at alarmingly higher rates. So I have merged the racial data in addition to the current data. This particular graph shows the total percentage of different races affected. As you can see, for the state of California, the percentage of white community affected is around 19%. and Latin community, which affected is around 55%. The next graph shows how each race contributed to the increase of COVID cases. From this graph, we can see that the Hispanic races affected most when compared to the other races.